Case study number 3, temperature compliance. A colocation customer was struggling with reducing their energy consumption and maintaining temperature compliance within the service level agreement referred to as SLAs. SLA breaches were frequent and significant. They invested in white space cooling optimization, referred to as WSCO, and this is what was found. They installed WSCO into the site and monitored the performance over the course of 2 weeks to establish the baseline. During this period, many of the rack temperatures did not change and stayed between 80 and 90 degrees Fahrenheit. This site consists of 5 crack units with EC fan control and approximately 78 active racks in the Colo space. In their effort to save energy, 2 of the 5 units were operating under the existing control. To distribute cooling from less units, they had added several perforated tiles to increase airflow. By leveraging IoT devices distributed throughout the racks gathering granular data, it was clear that there were still issues at the rack inlet. We see here in the room that there's several sensors that are red, indicating that they are over 4 degrees above the recommended ASHRAE set points. And here, where the sensors are yellow, we see that there are instances that the sensors are over 80.6, but not more than 4 degrees above the high set point. Once the system was given control, it began learning the environment. It turned additional units on and ramping fans up and down to satisfy the rack temperature sensors that had been over the high set point. The result was overcooling of the room, which we see here in the sensors that are in blue. To address this, it required physical remediation, replacing perforated tiles with blank tiles to close off areas that were too cold and direct air to where it is needed. This is the result after airflow remediation and AI optimization. We now see 3 units running with EC fans being modulated to manage temperature control, and all of the sensors are within SLA thermal compliance. This trend shows the timeline of the data from the baseline monitoring period to the system in full control. This is hourly rack temperature data for 1 month. Baseline period is September 8th to September 20th. The rack temperature sensors are monitoring the air intake at the racks in the data center space every minute and show that SLA breaches in the non-compliance. During this period, we tested and executed final configuration settings in the system. We see the space get colder with the highest temperature going from 75 degrees down to 55. From the end of day September 22nd to October 4th, we allowed AI to relearn the room, study the influence in the space, and make controlled decisions to automatically manage the temperature. October 5th began the remediation process, removing perforated tiles and adding blank tiles to restrict unnecessary airflow. This allowed the system to balance the airflow properly in the room and maintain temperatures within the required SLA. We see the temperature in the space warm up but remain within the desired range of 80.6 to 64.4. By October 7th, we see the system has learned the operational requirements of the room. The temperatures at the rack are now in a tighter control and maintaining the proper temperatures. After extracting the temperature and crack unit interval data, we ran an analysis to determine the SLA breaches or temperature exceedances to measure the improvement of temperature control. We can see there that the quantity of exceedances measured greater than 80.6 degrees was 21.8% of the time. And the distribution of exceedances ranged from about 82.4 to the 99.5 degree Fahrenheit. After the system was in control, we see the entire facility is now SLA compliant and the quantity of exceedances were reduced to 1.8% with 0 exceedances greater than 82.4 degrees. But what about the power consumption? This customer had originally tried to reduce energy consumption by only operating 2 of the 5 cooling units. Here's the data. This is the baseline with 2 units on at 28.4 kW. Deploying the system with the goal of eliminating exceedances, AI turned on an additional 2 units and raised the power to 35.4. By leveraging real-time data to guide airflow remediation, AI relearned the environment and safely turned off 1 unit, and we see the power consumption at 28.9, basically the same amount as before the system was installed.